Hello everyone. Today I'll be showing the presentation part of my project recovering from a node failure in wireless sensor actor network with minimum changes in topology. To understand our project, we must first learn what is a wireless sensor actor network or WSAN. In WSAN, there will be a bunch of sensor nodes and actors nodes. The sensor nodes are used to sense the environment and the actor nodes are used to perform the action. A real-world example is an automated fire extinguisher. Here the smoke detector will act as a sensor and the water repellent will act as an actor node. Another example is military surveillance where the camera is a sensor and alarm is the actor. So what our project deals with here, in case any actor node fails, we try to replace them in such a way that the topology is not disrupted in any way. So there are three modules in our project: AODV route discovery, distributed routing algorithm, network topology management technique. So this is our first module, AODV. So it uses three types of packets here, which we'll be seeing later. So this is the first packet, RREQ. So before sending data from the source to destination, we must first find a path. So as you can see in the diagram here, the source is trying to find its destination. In order to do that, node number 1, which is the source in our example, will flood RREQ packet to its neighbor nodes. So as you can see, the RREQ packet is going to 2, 3 and 4. 2, 3 and 4 realize that I am not the destination. So in turn, they will forward it to the other nearby nodes. This process goes on till the RREQ packet reaches the destination. After the packet has reached the destination will send a response message, which is RREQ response. So in order to do that, the destination in our case, which is number 8, will flood the network with RREQ message. As you can see here, the destination 8 is sending RREQ message to 6 and 7, which in turn realize that I am not the source. This RREQ message is forwarded until it reaches the source. So after the message reaches the source must realize which path has the shortest hops. That is the minimum number of nodes between the path. As you can see, the path from 8, 6, 2 and 1 has the minimum number of hops when we compare to the other two paths. So this is the shortest path and this is set as the route for transferring data between node 1 and 8. So this is link breakage. In case this happens, RRER packet is sent. So when sending RREQ message for finding the destination, in case node 6 is not able to send the RREQ packet to node number 8, so what node number 6 will do is send an RRER packet to the source saying that I am not able to reach the destination. This is number 2 of our module, distributed routing algorithm. So the sensor nodes, which I mentioned before, will periodically send heartbeat messages to all the actors. The heartbeat message is used to sense the health of the actor nodes. If the actor nodes are below the recommended health level, the sensor node must take some action to replace it with a healthy node. This is our third module, network topology management. In case there are any failures and we have replaced it with another node. So the replacement must be done in such a way that the network is not disrupted in any way. We do this by network topology management. System architecture diagram. This is similar to the wireless sensor actor network diagram which I shown before. There will be a sensor which is used to sense the environment and a bunch of actors which are used to perform some action. Data flow diagram shows the modules, that is AODV, that is used for finding the route, failure node detection, that is DSR, distributed routing algorithm, and network topology management for replacing the actors in such a way that the entire network is not disrupted. Existing system. As I mentioned before about AODV protocol, in the existing system AODV is not used. In the existing system we pre-calculate the route. AODV does not do that. Pre-calculation means the path between the sender and receiver is already set. So in case we want to send data from node A to node B with a pre-calculated path, while sending it will not check the integrity of the path. So during data transmission, if the path is broken, there is a wastage of bandwidth. So we solve this with our proposed system. That is by using a reactive type of protocol. So before sending data, the integrity of the link is checked. Nothing is pre-calculated here about the link integrity. So there is lesser chance of data loss. These are the screenshots of my project. I'll be explaining this with a complete video later. This is sample OTCL code. The front end is OTCL and the back end is C++. So in our simple code, we are showing how to create 4 nodes, set N0, set at1. This is used for declaring the nodes similar to C. And the next is NS duplex link N0 N2. So we create a duplex link between N0 and N2. 1 MB is the data transfer speed, 10 ms is the latency, drop tail. So using drop tail, a queue is set. So if you receive data more than what the queue can handle, we drop the packets. This is called as drop tail. So as you can see, we have to arrange the position of the 4 nodes which we created. This is done by setting the orientation. As you can see, we have set orientation of N0 and N2 to write down. Similarly, we have done this for other nodes also. This is a sample program for sending data from node N0 to N3. As you can see, we are generating UDP traffic. We have set the packet size, interval, etc. Hardware and software requirements. This program runs on a Linux distribution with network simulator to install. Hardware requirements are Pentium 3 processor, RAM 1 GB or higher. This is a literature review. So that's it. This is the end of the presentation part.
Hello everyone, today I am going to execute my project recovering from node failure in wireless sensor actor network with minimum changes in topology. So the first thing to note here is that this project runs on a Linux distribution. So you must have a Linux OS with network simulator 2 installed. First thing you have to do is open terminal. This can be done by pressing Alt Control T or from the home folder. Next we have to navigate to the place where our file is located. In my case it's in documents. The file which has to be executed here is nodebackup.tcl as it's shown here. So what's happening now is the distance between the nodes are being calculated. We have to wait until this process is complete. After the distance calculation has been completed, we have to move to this file. The sensors are indicated by blue color and the actor nodes are indicated by green color. So what happens here is sensor nodes, they are going to sense the state of the actors, whether they are healthy or not. If the actors are not healthy, they will change their colors to red. We can also forward the simulation process by using the slider over here. The things which are getting dropped here are packets. As you can see here, the color of actor 5 has changed to red, which means it has entered its critical state. And the color of actor 25 has changed to yellow, which means it's going to act as a backup for actor number 5. Now what's happening here is the content of node number 5 is being transferred to actor number 25. Now actor 13 has entered the critical state and actor number 1 is acting as a backup for it. Next thing that is happening here is topology management. That is making changes to the topology in such a way that many of the nodes don't get affected. That's it, our topology management is done. Here the nodes are moved in such a way that the network is not disrupted in any way. The communication can still go on even though actors 5 and 13 have failed. Next we have a graph here showing the packets that are lost. As you can see in the proposed system, the amount of packets that have been lost is very less compared to the existing system. So the proposed system is a way to go. Thank you for listening.